Welcome to this quick revision session. Ordinary level mathematics, vectors part 1 with Was Moses Song, your mathematics teacher. We'll be doing the revision by a presentation. Before we begin, the first key point, two vectors u and v are said to be parallel if vector u is equal to k times vector v, where k is a scalar. So for us to show that two vectors are parallel, we just verify if they satisfy this condition. Secondly, two vectors u and v are said to be perpendicular if the dot product of u and v is 0. So when you want to verify that two vectors are perpendicular, just find the dot product of the two vectors and verify if the result will give you 0. Thirdly, if we have a vector diagram of the one drawn here, now, such that the vector AB is divided at a point X by two fractions M and N. That is, the vector AB is divided at the point X in the ratio M is to N. Here is what will happen. So if the point X, this point X divides a vector AB in the ratio M is to N, as we have it shown here in the diagram, the first thing is to find AX. This is what we do. We look at the proportional part for AX, which is M. So AX, the vector AX will be given by the rational part, which is M over the sum of ratio M plus N times the whole vector, and the whole vector is AB. So we have M over sum of ratio M plus N times AB. Or if we are moving in the opposite direction, instead of AX, if we are looking for XA, we follow the same steps, but the whole vector instead of AB will be having BA. That is why here the vector AXA will be equal to M over sum of ratio M plus N times BA. Secondly, for the vector XB, to find XB, we do a similar thing by using what? The proportional part of that ratio, which is N over sum of ratio M plus N times AB, the vector AB. Or again, if we are moving in the opposite direction to this arrow, we will be looking at BX instead of XB, and BX will be equal to N over sum of ratio M plus N times BA instead of AB. Finally, if we have a vector U given by Xi plus Yj, this is a general vector. Then to find the magnitude of that vector U, mark U will simply be equal to the I component, which is X squared, plus the J component, which is Y squared. And when you sum the squares, you take the square root. So after looking at these key points, we'll look at some application exercises. Exercise 1. Given OP equals 2i plus 3j and Ochia equals 3i minus 2j. Find A, find the magnitude of PQ. B, show that OP and Ochia are perpendicular. This question is taken from GCE 2010 paper 2. We look at the solution. A says we should find the magnitude of PQ. To find the magnitude of PQ, PQ is a vector. We first of all find the vector PQ. And to find the vector PQ will be OQ minus OP. Your teachers must have already explained this to you in class. Now, we know that OQ is 3i minus 2j, 3i minus 2j, minus OP is 2i plus 3j. Bringing the I and the j components together, Here we have 3i minus 2i. We bring them together. Negative 2j minus 3j. We also bring them together. 3i minus 2j gives 1, and negative 2i minus 3j gives negative 5. So in this case, for us now to find the magnitude of PQ, and using the formula that we had just seen at the key point, we take the component of I, which is 1 squared, plus the component of j, which is negative 5 squared. We sum the squares and we find the square root. And when this is done, 1 squared is just 1. Negative 5 squared is 25. 1 plus 25 is 26. And the square root of 26 remains root 26, since 26 is not a perfect square. We move to the B part, which says show that the vectors OP and OQ are perpendicular. For us to show this, we just need to show that the dot product of the vector OP and OQ is equal to 0. To do this, we start by evaluating the dot product. The dot product of OP and OQ is given by, you write at OP, which is 2i plus 3j, dot, you write at OQ, which is 3i minus 2j. Here, the dot product simply means multiplying corresponding components together. Now, 2i times 3i. 2i dot 3i just gives 2 times 3. That is why you have, for the I components, you just have 2 times 3. And for j components, you just have 3 times negative 2. That is how we find the dot product, as you have been taught in elementary vectors. Now, when we do that, 2 times 3 gives 6, and 3 times negative 2 gives negative 6. And we all know that adding a number with the negative of the same number gives 0, since negative 6 is the additive inverse of 6. So this gives 0. And since the dot product has given 0, we can conclude that OP and OQ are perpendicular. Here is a second application exercise. The figure shows a vector diagram such that OA is equal to vector A, OB is equal to vector B, and the ratio AX is to XB, AX is to XB is equal to 1:3. Express AB and XB in terms of A and B. This one has been taken from GCE 2017 paper 2, section B. As a solution, A says, or the first vector says that we should express AB in terms of small a and small b. Now, we know that to obtain AB, we move to the diagram. To move from A to B, since there is no direct access here, we need to move backwards. We move from A to O, and we move now from O to B. We use the directions to which the vectors are known. And there is something we need to know. Moving from A to O, we see that we are moving in opposition of this arrow. And since vectors are specified with directions, whenever we move in opposition to the direction, the sign also changes. So if OA is A, then AO should be negative A, as you can see clearly here. AO is negative A, and OB is in the actual direction, which is B. So in OB, the B is maintained, positive. So negative A plus B is the same as B minus A. Therefore, we are saying that the vector AB is B minus A. Secondly, for for this xb, this is xb. For xb, to express xb, we bring this ratio and apply it in the diagram. We are told that the ratio ax is to xb is 1:3, which means that ax takes the proportion 1 and xb takes the proportion 3. So if we bring it 1 and 3, using the key concept we have just learned above, we see that xb will be given by the proportional part, this 3 over sum of ratio 1 plus 3, which is 4, times the whole vector ab. That is why you have 3 over 4 times ab. This implies xb is 3 over 4 times, we bring the vector ab and replace it. So we have already obtained the vector ab to be b minus a, which means that ab is replaced by b minus a. And 3 over 4 times b minus a simply reduces to 3 over 4 into b minus a. And that is our solution. Now we move to the third application exercise. This one here is 3, is just a typing error. Given 3 vectors, p equals 4i minus j, vector q equals negative 3i minus 4j, and vector r equals 5i plus aj. Find a, the vector p minus 2q, b, the value of the scalar a for which r is parallel to the vector p minus 2q. The source of this question is GCE 2015, paper 2, section A, question 12. Now, as a solution, A says we should find the vector p minus 2q. We know the vector p, we know the vector q. We just replace those vectors. P minus 2q is equal to, we replace p by the vector 4i minus j. We replace q by the vector negative 3i minus 4j. Now, to simplify this, we first of all multiply 2 into the vector q, as we can see here. 2 times negative 3 is negative 6. 2 times negative 4 is negative 8. Now, we have the vector p now minus the vector 2q in bracket. And simplifying this, we bring the I components together, and bringing the I components together, we have 4i minus negative 6i. 4i minus negative 6i. This is what we have, minus j minus negative 8j. This is minus j minus negative 8j. And this gives us the same as 4i minus negative 6i gives negative, negative here gives plus. So 4i plus 6i minus j minus negative 8j gives negative minus j plus 8j. 4 plus 6 is 10, and negative 1 plus 8 is 7j. So p minus 2q is 10i plus 7j. B says we should find the value of the scalar a for which r is parallel to the vector p minus 2q. Now we know that r is parallel to p minus 2q if and only if the vector p minus 2q can be expressed as a scalar multiple of the vector r. And if this is to be done, you have that p minus 2q will be equal to a certain k times vector r, where k is a scalar. Now, we have expressed p minus 2q and simplified it to obtain 10i plus 7j, which means that we equate 10i plus 7j to k times r. And if that is done, you see that 10i plus 7j will be equal to k into 5i plus aj. These two vectors can only be equal if 5k is equal to 10, giving us k to be 2. And if our scalar k is 2, it means that the j components must also balance up. And for j components to be the same, 7 must be equal to k times a. And since we are equating the components of j, 7 must be equal to k times a. And we know that k is 2. So 7 is equal to 2a. To find a, we simply divide both sides by 2, giving a to be 7 over 2. Here is the end of our application exercises. But before we end the lesson, you will have to take one exercise of practice. This is an exercise that you practice for proper understanding of this particular quick revision. So thank you for listening. If you have not yet subscribed to our channel, to my channel, please do so, because there will be very interesting concepts in mathematics for you to just upgrade your skills. Thank you for listening.